This video is the beginning of the final exam review for Math 1111. On the review sheet that's provided in GoView, it's broken up into topics, and so I'm going to try to break up the video in terms of the topics as well. And the first topic on the review sheet is simplifying expressions. I'm also going to add in some supplemental questions as we go. It's a pretty safe bet if I've added a supplemental question that there's one similar to that on the actual final exam. So the first problem under simplifying expressions says, simplify the expression, the cube root of 8x to the 9th, y to the 12th, divided by x to the 5th, z to the 7th. And so the first thing that I want to do is deal with the radical. And so we need to think about, do we have pairs or a set of 3 of anything under the radical? So I have the cube root of 8, and 8 would be 2 times 2 times 2. If you need to, go off to the side and note that 8 is 4 times 2, but then 4 breaks down to 2 times 2, so that you have 2 times 2 times 2. Then we have x to the 9th, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9 x's and 12 y's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, and then since it's a cube root, remember we're looking for groups of 3. Okay, so I have a set of 3 x's, or 2's, excuse me. I have one set of x's, a second set, and a third set. And I have one set of y's, 2 set of y's, 3 set of y's, 4 set of y's. Now remember, I still have that denominator there, okay? I forgot to write it, but the denominator is still there. I still have x to the 5th, z to the 7th in the denominator. So then all those things where I have sets get to come out of the radical. So I have a 2, and I have x, which occurred 3 times, y, which occurred 4 times. There's nothing left under the cube root, and then I have x to the 5th, z to the 7th. And I'm almost home free, but I notice that I have 3 x's in the top and 3 in the bottom. Remember, the rule is you subtract the exponents, and I'm going to have 2y to the 4th with 2 x's left in the denominator, because when you do 3 minus 5, you're going to take 3 from the 5, and so that would leave 2. So this is your answer. 2y to the 4th, x squared, z to the 7th. All right, let's look at the next one. The next one is kind of all jumbled up. It's the square root of x to the 7th, y to the 3rd, x to the 5th, z to the 4th, y to the 7th, all over y squared. The first thing I'm going to do here is underneath the radical, I have some x's, and then I also have some y's. I'm going to go ahead and combine them together. And if you remember, the rule is when you're multiplying with the same base, you add the exponents. So I have x to the 7th and x to the 5th, which will be a total of x to the 12th. I have y to the 3rd and y to the 7th, which will be a total of y to the 10th. I still have z to the 4th, and I also still have y squared in the denominator. The next thing I'm going to do, continuing to work under the radical, is deal with the y's. So 10 minus 2 would be 8. So I have x to the 12th, y to the 8th, z to the 4th. And there's nothing left in the denominator. Okay, so then I want to find pairs of 2. So if I think about it, if you need to write it out, we can do that. We'd have 12 x's. 5, 6, 7, 8, 9, 8 y's, and 4 z's. Okay, and then we're doing a square root, so we're going to look for pairs of 2. So I have 1, 2, 3, 4, 5, 6 pairs of x's. So I have x to the 6th. I have 1, 2, 3, 4 pairs of y, so y to the 4th. And then I have 2 pairs of z, so z squared. So ultimately my answer is x to the 6th, y to the 4th, z squared. Okay, then we're going to look at a supplemental question. It asks you to simplify the square root of 50x squared y to the 3rd. So the first thing I'm going to do is kind of go off to the side here and see what I can do about 50. I'm going to come off over here to the side. 50 would be 2 times 25. 25 would be 5 times 5. So I can break down 50 into 2 times 5 times 5. I would have x times x and y times y times y. It's a square root, so I'm going to look for sets of 2. I have a set of 5. I have a set of x's and a set of y's. So those things are going to get taken out of the radical. So I have 5x, y, and left under the radical is 2y. So your answer is 5xy on the square root of 2y. Then question number 3 off the actual review sheet is a rational expression problem. It asks you to simplify it. It's a multiplication problem. And the first thing we want to do when we're dealing with these particular type problems is we want to factor everything or break everything down as much as possible. So if I start on the top of the first fraction, x squared minus 25 is the difference of 2 squares. And by the way, that formula for the difference of 2 squares is actually at the beginning of the final exam, and it factors into x minus 5, x plus 5. Then I'm going to look at the denominator, 5x plus 20 has a common factor of 5, and I'm left with x plus 4 times, looking at the second fraction, x squared minus 16 is the difference of 2 squares. It's x minus 4, x plus 4, and then in the denominator, x plus 5, it's already broken down as far as it'll go because you have an exponent of 1 on the variable. Then remember, we simplify on the bow tie. So anything that's diagonally across from one another, so in this case I have x plus 5 and x plus 5, which will divide out. Then looking at the other diagonal, I can divide out x plus 4 and x plus 4. Then on the verticals, there's nothing to simplify on the left, and there's nothing to simplify on the right. So ultimately, my answer is x minus 5 times x minus 4, all divided by 5. And there's your answer. There's also a supplemental question for this one. It's a little bit trickier because it involves some higher exponents, so you have to do some factoring. But again, the formulas for difference of 2 cubes, different sum of 2 cubes, difference of 2 cubes are provided at the beginning of the final exam in the formula list. So again, we begin first of all by factoring, okay? So I have x cubed, and I can take out an x. And if I take out an x, that leaves me with x squared minus 9. But x squared minus 9 factors into x plus 3, x minus 3. In the denominator, I can factor out an x squared. If I factor out an x squared, I'm left with x cubed plus 27. X cubed plus 27 is the sum of two cubes, so we can factor it using the formula. To get x cubed, I would have cubed x. To get 27, I would have cubed 3. We keep the plus sign. And then to get the second piece, we square the first term, which is x squared. We square the last term, which is 3. We multiply them together, and then it's always minus and plus. Okay, so then we factor the other fraction. X squared minus 3x plus 9 does not factor. In the denominator, I can take out a common factor of x, and I have x times x plus 3. Then again, I'm going to simplify on the bow tie. Remember, anything diagonally across from one another. So initially, I can divide out an x and an x plus 3. Whoops, excuse me, x plus 3, not minus 3. Okay, let me put that back. Then on the other diagonal, I can divide out x squared minus 3x plus 9. Let's see, on the vertical, on the left, there's nothing, and on the right, there's nothing. So we're left with, so our final answer would be x minus 3 divided by x squared times x plus 3. Okay, that gets us through the first grouping of questions. So I'm going to stop there, and then we'll come back and pick up with the next grouping, which has to do with solving equations in one variable.